Hey, good morning. Laptop fix Nasa. Electroreb. Good morning. Just another day where we have to fix stuff. Nemanja, good morning. I'm okay. Sunday morning. And I need to finish the job lot because I have a lot of the other jobs, like normal jobs. Wow, what is that? 1 second. Moldo, good morning, Nata. What is that? Huh? It's like someone made it on purpose. Yeah, no way for me to fix something like that. I mean, clearly this was not burned. You can see the layers are fine. So someone ripped it off on purpose. Hmm. Yeah, I can fix this one, but not this one. Jerry, good morning. How is everyone, huh? Everyone fine? You enjoy the day? I have a problem with an iPad Pro 11 on the display connector. A specific pin should be grounded, but I'm getting a diode reading. If it should be grounded, just connect it to ground. Probably it's a fuse there, and the fuse is burned. Milan, good morning. Any easy pizza? Zoltan, good morning. Green screen, good morning. Lamprots, good morning. Check mobile. 20 volts. Pressing the power button, and we have a cracked screen. Yeah, the screen is gone. And the battery fully charged. Giorgio, good morning. If I remember from iPhones, the fuses they are from the ground, which is coming from the screen, and the fuse we ground. Some fuses we ground and some fuses we plus. Yeah. So it has to be ground, just make sure it will be grounded. Check mobile. Dead. Dead. Dead, dead. What is here? This is not me. No coffee tone gravity. I had my coffee. So I'm just ready for work. You think the MOSFET burned? Huh? Soros, good morning. No, it's not sure here. Fuses are good. All good. Then we have some fuses here. This one is good. And this one is good. Then what is wrong with this board? Wait, the board is working from one side. 900 milliamps. But went off. Is the port. Okay, let's see if we have picture. No picture? Ooh, the CPU is mad hot. That should be fine, huh? It's rebooting and that's okay. Yeah, probably it's working. Huh? Super hot. Hi, Prashito, good morning. Free amps. I can see free amps there. We have picture. Okay. So the board it is working. Button cover temper detection error. Ah. Yeah, okay. Because of this switch, right? No, not this one. No, must be another one. Or maybe this one. Yeah, let's take the board out. So how you guys are spending the Sunday? I'm going to watch Spider-Man. Not working. Work, work, work. Yeah. Pick music. Hello from Poland. Sneezy. Good morning. Working, huh? Everyone working. Can't believe. No one is doing barbecue and stuff. Moonrose, good morning. Wow, someone work here. Someone try something. Actually, but we have no foil there. Maya, yeah. Good morning. Wait a second, here are some components missing. So this one is missing, and it's fine. But this one is not fine. Here is a capacitor, here is a broken diode. Oh, what is this? I mean, this port is not even soldered. Hmm? Yeah, okay. Can I connect this separate ground to, yeah, definitely. Definitely you can. When I grill the fish I caught? Wow, really? You're a fisher guy? Different grounds are because of the ground noise, but you can connect it. Should be fine. Let's solder the port. Also, actually reflow the port quickly. Good. So this one it is soldered. I caught a big pike, almost 1.2 meter. Wow. Wow. I used to fish back in Romania. But here is more complicated. Nothing. So this one is working. And it's working. Good. Wait. This one is working from this side. And from this side. Oh, wait a second. Not this one. This one. This one is not working here. Wait, it's working here. Tom, good morning. Okay, let's put back the components. Wait a second, let's check for short first. Because we have some broken diodes there. So this one is fine. Then here is fine. Fine. But still, why is not charging from one side? What is this? Okay, so some dodgy technician tried to solder that port. Azo, good morning. Cecil, good morning. Maria, good morning. Thank you. Fishing is like therapy? Yeah. Yeah. It is. You just sit there, quiet, you have time to make order on your mind. It is working. Check that, 19. Yeah, working fine. Okay, let's solder the port properly. And actually, I love eating fish. Sometimes I'm going like 4 o'clock in the morning to the fish market in London and I'm buying fish. Usually carp. And Diana has like a nice recipe to cook that carp. Good. Need license. That's what I heard. You need some kind of license. But even with license, you can't fish. You have to pay for being able to fish. So it's a little bit more complicated. And even if you catch fish, you have to release the fish, and for me, it's kind of pointless. If I catch the fish, I want to eat that fish. I don't want to release the fish. I mean, for me, the pleasure is fishing, but then eating what I caught. What I caught. Good. We need a capacitor. That's all what we need, a capacitor. And we have the capacitor. Good. Like that. And now this should be fine. Should work on data transfer. My neighbor is going with a motorcycle. Good. Nice job. It's just a charging port. It's not a big deal. No big deal. My daughter has the same laptop and ruined with liquid metal. Don't apply thermal paste after liquid metal. Apply a thermal pad. Sorry, yeah, thermal pad, yeah. The PTM pad. Because you already have liquid metal on the heatsink. Yeah? So the oxidation process, it will continue even if you clean it. But with the PTM pad, you limit that kind of stuff because the PTM pad is like solid when it's cold. I mean, it will work, but you'll get better thermal transfer if you use PTM pad after liquid metal. Mati, good morning. Dodgy fishing? Nah, I know people they were doing. No, they have a device with high voltage, and they were going on the like mountain rivers, and yeah, they will electrocute the fish and catch the fish. How much laptops left in lot? We have like 4 more. So it's more easy to use the electricity, Mati. Fish teaser. I mean, you don't need that much voltage. Like if you have an inverter from 12 to 220, that should be enough. And it will not kill the fish. It will make the fish dizzy, and you can catch them with your hand after that. From what I seen, I didn't do it. It's kind of like too brutal. In Germany, everything is fun. It's illegal. Yeah. The world is changing. That's the thing. And it's changing on such a way you don't have a choice. So you let the other people to decide for you. and kind of feels bad if you ask me. This name's democracy. Yeah. You can see the way how the world is changing. Based, you go online and you see. I seen like last week or 2 weeks ago, a woman sue the McDonald's because the fries were too hot and she got burned, and she won. She won the process, and this is insane. This is insane. I mean, you must be retarded if you cannot figure it out. You know, the fries which you just got them, they are hot. I mean, what kind of judge can, you know, give a win on this case? So yeah, that's why we cannot have good stuff. Probably now they will lower the temperature of the fries, and yeah, you cannot have like hot fries anymore. That's ridiculous. Yeah. Cold fries, cold coffee. Yeah, that's why we cannot have good things. Yeah, that's why. Whatever is there, the people it will abuse. Good. What country? I don't know. I'm assuming it's UK. I don't know. I don't remember. How is the weather there? Today is fine. Today is actually the finest day. But starting from today is like 26, but then tomorrow 29, then 27, and hopefully it will cool down for a while. But yeah. Okay, so what's the problem with this one? Just check mobile. Okay, let's check. Five volts. That's not good. This is a PD controller issue. So this here is 5 volts without current, and here is five volts with 200 milliamps. Machine free keys, yeah. Customer it will sort it if the motherboard is good. He has spares. Good. Yeah, we have to take the board out. Proper? Cold and windy? Where? Where, Ronnie? Where? Which country? South Africa. You lucky then. Let's see. Let me be sure I'm not doing stupid things. Like yesterday. I need some tape. Tape? We don't have winter there? Getting older? Yeah, when I need to see properly, I'm using glasses. So that's what you can do. You can use your glasses if you can't see properly. I have the same problem like you. I'm losing my eyesight. It's getting worse and worse. JFix, good morning. What's going on, JFix? So this one 5 volts with nothing. And this one 5 volts. And it's rebooting, it's going to 19, then rebooting. Nah, this must be a PD controller issue. Let me check first something. No, it's not short. So we're gonna replace the PD controller. Looks like a Lenovo. A lot of Lenovos. So we have a TPS chip. We AD at the end. AD. Come on, I can't do it with this temperature. No. You know what? Can't do it. It's too low. I can't work with like 360 on chips. 390. I screw it up with my solder bolts. This one needs AE. This one This one, I can't see it. It's AD. Yeah, that's what we need, AD. Check with your doctor. You may have. Oh. I'm okay. I'm not that old. Look old, but I'm not that old. Great. Okay, this one went fine. You're older than me? You think? I'm like in my 50s. Good. Good, so the chip it is moving. Change your diet. Eat me like me and you'll feel younger. What do you mean? I eat meat. Even yesterday we had sausages. I love meat. I love meat. What is the difference between AD and ED? It's just different chip. I don't know. You have AD, ED, then you have AC. Yeah, it's different. 5 volts. So same story here. And here the same story. It's exactly the same story. Wait, this one is not even coming on anymore. Nothing. That one just died. 5 volts with like 700 milliamps. And this one is 5 volts. So what is taking 700 milliamps? By the curiosity. Now here must be the port on this. $700, it's a lot. It's a lot if the board didn't start. Maybe the board started. Because it can start with 5 volts. You have 5 volts, then you have this boost power supply which will raise the voltage. And we have a flashing stuff there. MOSFET. You can see how it's flashing. And here the PD controller is getting hot, and I don't think it's supposed to get hot. Yeah. But let me check the main power rail by the curiosity. So the main power rail is The fan is spinning. Check here with 5 volts, you can see. The fan is spinning, so the laptop just started. So the input is 4.7 and the output is like 5.27. That doesn't look good. Classmaster, what we are repairing today? Just some Lenovo's. Wait, why the inverter is not doing the job? Huh? I mean, I should have like 12 volts there, something like that. So coming with the power supply here, it's taking 1.5 amps, 1.3, and the board started. Or didn't start. It's taking insane amount of current. Even 1.6 amps, it's a lot. 1 second. Let me see what's going on here. So the main power rail is here. It's taking 1.4 amps. What chip is this? Why the chip is getting hot? Then we have a fuse which is getting hot. That fuse. Okay. But why the chip is getting hot? This is a PD controller thingy. Wait a second. This is not supposed to get hot. This chip. What is flashing? I mean, what is not flashing? This is like a Christmas tree. Everything is flashing on this board. I'm gonna replace this one. Good. I'm gonna take the chip from here. Okay. And the chip is soldered. 1 sec. Okay. Eli, good morning. Is the same duck here? Yeah. Nope, it's a goose? Okay. First connect the battery. Nah, I should work without. Plug in the charger. This is not doing anything. And this one, 5 volts. Here is doing nothing. So it's not taking current like crazy anymore. Basically now it's taking no current. No current. So coming with the power supply. On this, here at the output of the MOSFETs. And now the board is fine. Check there, like 1.1 amp. The board just started. We have the charging light there. Board is rebooting. It's looking good. So the only problem we have right now is the PD controller. PD controller, the ports. Yeah, let's try just a short flow on both ports. Good. Let me take out the nozzle. Okay, this port is stuck with some glue on the back. Dodgy PD controller? Can be. Can be. This one now it's working with 5 volts. This one still not working. This one it is working with 5 volts. And this one is not working. So this one is not working at all. Okay. I think we should reflow like a proper reflow this chip. Reball. Reball, a proper reball. How we are doing a proper reball on this chip? You know how, right? I can bet you know. Proper reball on my book is pushing the chip down. That's a proper ball. Now every solder ball is equal behind of the chip. You didn't know that, right? Press it down, yeah. Five volts with 200 milliamps. That's a good sign. And this one still not working. 5 volts with 150 milliamps. Okay, that's weird. I think we just move a dodgy PD controller from another board. From a simple reason, I cannot explain the current difference between the ports. 150 milliamps versus 200. You see, I cannot explain that. So should not be a difference. That's what something made me believe actually that this chip is not good. I don't remember it was AD, AE, what was original here? So this one is AD. And the original one, what is the original one? Here. And the original one was AD. Okay. Another new? Yeah. We can find another new one. No, I can't work with low temperature on chips because I'm hitting the board a lot. And that's not good. When you hit the board a lot, you will see this kind of stuff, like solder is coming out from the components. And you don't want something like that. You don't want to spend time with the heat on the board. This is AE. And this is AD. Yeah, we need something like that. Perfect. Perfect solder balls. Good. And the chip it is solder. Good. Let's see now. 5 volts with 180 milliamps. But this one it's working. 5 volts with 170 milliamps. Okay. 5 volts 170. 5 volts 180. So both ports are working on the both sides. The problem is in non-negotiating the he's not negotiating with the EC chip. He's not speaking with the EC chip. Why is that? I went for a smoke. Any chance? No, no smoke. So everything is fine now. He's taking 170 milliamps. And the main power rail is 0.5 watt. And the input is 0 volts. Wait a second. What is this? The input is 0. Wait, this one is not working. The 170 milliamps is going somewhere else. Somewhere where it's not supposed to go. One second. Something is wrong here. I mean, how the PD controller can get hot? I don't understand. We replaced the PD controller. Why the PD controller is getting hot? Why? We have no output from the PD controller. For some reason. What do we have here? Here is fine. Here is fine. Then here is fine. We have a capacitor with like 3 ohms. Okay, that's interesting. Capacitor with 3 ohms. Huh. One second. So here is like 2 ohms and here is 0. Okay, there is ground, here is plus. So if we are coming, can have LDO? They have LDO. What do you mean can have? They have 1.8, 3.3. They have. But we have a shorted capacitor there. So coming with current, 1 volt on this capacitor, which one I said? This one, right? It's taking 400 milliamps. And what is getting hot? I can't see anything getting hot. That chip, the one we replaced it from the other side. I mean, check that corner. You can see that corner is getting hot. It's from the other side. The one we replaced it. This one. Why? Where is the schematic? No, we don't need the schematic, right? No, I'm just joking. Say hello to a little friend? Nah, not really. Doesn't work like that. That capacitor is good, it's not shorted. Here we have 2 ohms. Why we have 2 ohms there? Oh, that's my question. Why we have 2 ohms? Coming with current. Coming with current exactly there. I mean, check that chip, and we replace the chip. We took the chip from another board. Why this is happening? We replace that chip. We replace it. And I'm pretty sure it is sold. Oh, it's kind of bent, right? Kind of bent. I think actually the chip is not soldered properly. Wait a second. Now definitely it is soldered properly. Do you wanna bet? That resistor is fine. Don't worry about that one. You wanna bet? Do we still have short there? We still have short. We still have 2 ohms. No, this chip is not good. This chip is not good. Let me take out the chip. Let's check again. No, it's not short anymore, you can see. No, that chip was dodgy from the beginning. That chip was dodgy from the beginning. So I'm gonna grab another chip. Wait, what is that? Why this chip is bent? Hmm? Yeah, and I'm gonna move the chip on my board. P number 1 here. Let me check the sold. Oh, what is here? What is here? Yeah. Okay, we're gonna have to push the chip down. Oh, what? Good, let me get some flux. Steve Computers, good morning. Late? Nah. Nah. How you can be late? I think it's a ESD over power protection. You think? I don't think so, because it's connected to a pin to the PD controller. So this is a chip which is connected to a LDO output from the PD controller. I'm pretty sure about that. Did you rotate? Huh? Rotate what? Of course, it's pin number 1 there. Check that. No, I'm not doing that kind of mistakes. To put the chip on the wrong position. Let's check that pin, if it's shorted. We said this somewhere here. I can't really see. This one here is not shorted. Good. Plug in the charger. I see 19 volts, so 5 volts with 270 milliamps, but I see 19. This one is not working anymore. 5 volts with no current. And 5 volts with 19, then it's shutting down. Check that. What voltage was supposed to be on that capacitor? And now it's 5 volts with 200 milliamps. So here is supposed to be 3.3. You can see LDO 3.3. Now it's taking 200 milliamps because probably the main power LET is present. So the main power L, check that, check on the screen. Check on the screen, 12.3. You can see. That's why it's taking current. So now the current is justified, yeah? The problem is the other one is not working. So here I get a charging light, but here I get nothing. I get like voltage, but no current, nothing. And here I have the same chip like that. Yeah, same one. And this one is the same. So not sure what shall I say about this. No, both ports are they are supposed to charge. Someone sent me a schematic yesterday on Discord. Actually, schematic and board view. Can you believe that? And board view? Actually, 2 people sent me. Desktop. Let's open the board view. What? Why is not working? Open desktop. Board views. All files. Where is it? Where is it? I can't even see it. This one, yeah. This one, open. It's not working. Ah, can't believe. Okay, let me try to download another one. TVW. Maybe this one is working. Okay, this one. Yeah, this one it is working. Good. So what is this? U613. Well, we don't know. We need the schematic. 1 second. Save. Good. Perfect. So we need U6319. U6319. Yeah, where is it? Oh, enter. This one? Six three one seven. 6319. Check here. Oh, this is an important chip. 1 second. It's taking LDO from the PD controller and is moving the CC pins from one side to the other. This is an important chip. Actually, it's a very important chip. I mean, don't get me wrong. If it will be, from my point of view, probably I will remove the chip and I'll short the input with the output. No, 1 second. What is this doing? So this is the connector. What you see here is the USB-C. This one is the USB-C. Is the connector. Then, and you have another one, 6317, 6319. It is an important chip. So what you people are thinking about this? Huh? Where is my OBS? Connect the battery to see if the voltage is changing to 19. No. No. Laptop fix. Thank you. Yeah, that's the one I opened. Maybe rename it? No. It is what I said. ESD protection. I don't think so, JFix. I mean, check here, yeah? I think it's doing more than that. So you have oh, okay, so you mean ESD from here to here and ESD for this one? Yeah, okay, it's making sense. Yeah, can be. But why a ESD protection need 3.3 LDO? Huh? Not making sense, right, JFix? Why a ESD protection need voltage? So probably this chip is doing some switching here. Not sure how we can proceed. I think we should make sure this GPT is soldered properly. 6319, yeah, that's the one. Hmm? So we have 19, then it's switching off. Why is doing that? We have 19 and switching off. So that chip is for this port. But this port has a different chip. And this one is not working. Check here, nothing. So it can be the port. So what I want to do is actually replace that port. 370, 360. I want to replace this port. So the port is out. They complicate the things with the USB-C so much, so much. What happened in normal port? Normal port, we have the voltage no matter what, with no problems. Why they had to complicate so much the power input on a laptop? It's outside of my understanding power. Because you can see all problems, I mean 99% of the problems, the USB-C circuit on the laptops. I mean the laptop is fine, has no problem. The problem is the USB-C circuit. Why they have to do something like that? Probably they think, okay, the laptops, they don't have power issue. Let's create some power issues. Because that's what the technician can repair, power. Okay, let's create some power issues. They really try to get rid of the people repairing stuff. Because they can sell more. So it's just a win. They have nothing to lose. Yeah, where is my chat? I can't see the chat. Yeah, I seen that. I seen the Louis Rossmann video about washing machine drums. Yeah. Yeah, I seen that video. They will always pull the rabbit out like it's for the customer protection. It's for the customer safety. They will always do something like that. 5 volts with no current. 5 volts with no current. 5 to 19 with a lot of current. 5 volts. Wait, but it's inter check here, so the output is like 4 point something. Do you think actually it can be possible to be like a dead MOSFET? Huh? Solder balls. But not from here. So if I plug the charger and if I short the input with the output with the output from here to here, and no, still not taking current. 1 second. The input with the output. It's taking like 200 milliamp. 19 volts. No way. I have 19 volts on the meter. You can't see it. I have 19 volts on the meter and the board is coming on. So what is wrong, the MOSFET or the PD controller? Reboot technologies. I'm still watching the first Joblot. So what is wrong, the MOSFET or the chip? That's my question. This MOSFET or the chip? This one or the chip? MOSFET, okay. Cecil said MOSFET. In this case, we have to replace the MOSFET. Let me take out the heatsink because it's a little bit more complicated. it will be a pain to replace that MOSFET. Just because it has some glue on it, you seen it? Then even the next MOSFET has some glue on it. This means if the solder is blowing up because of the heat, yeah, we have to replace even the second one. Probably. That sucks. I will gladly short the MOSFET. No easy pizza? No. Try with MOSFET. Yeah, bro, but we have glue there. We have glue. Check here. Let me see the other board. So here, even here we have glue. We have glue everywhere, so I can't even move the MOSFET. Let me see if I can find MOSFETs without glue. MOSFETs without glue. What do you think about that? Huh? Good. We found MOSFETs without glue. But very possible we are blowing up the tracks when we are taking out the MOSFET. This is so risky. It's so risky. You have to trust me on this one. I can't do it. This is low temperature. I can't even work with low temperature. 1 second. Okay, let me understand what happened. What is the MOSFET? Let me find the MOSFET. I can't find it. For me, it looks like some kind of burn thingy. Here on this side. Those fuses, yeah, the fuse is never the problem. Fuses is always good. Okwalinga, good morning. Okay, the trucks are still fine. That's a release. But what I'm doing with the glue? Hmm? You know what? I'm afraid to not break the tracks. It's not looking bad. Why they are doing this? Why they are using glue? Okay, I think we can solder a chip here, a MOSFET. What I care actually from something like that, what I care is about the gates, yeah? Because those are together, here are together, together. So that's what I care, the gates. I know. So they thought if the MOSFETs are getting the solder from the board, then let's use some glue to keep them on the board, you know? They don't realize, wait, the MOSFETs are falling down because of the PD controller not supplying enough power to the gate, enough voltage to the gate. So it is stupid indeed what they are doing. It's making no difference. It just make the job harder for us. So I said we have some MOSFETs here, right? Yeah? No. Yeah, where is that board with the MOSFETs? Yeah, this one. I mean, we have to lift that MOSFET perfectly because we cannot reball. Okay, the MOSFET is out. Let's see. It's working. That's crazy. 19 volts, 800 milliamps, and the board just started. You can see that? Ah. And this one, 19 volts, 1 amp. Check here, working perfectly. What do you think about that? Just say it. 19 volts, 900 milliamps. 19 volts, 900 milliamps. So this was a proper hard job. I mean, we replaced the PD controller, replaced the port, even the port had an issue. Then we replaced this chip, then we replaced the MOSFET from the board. Can't believe. It's not even worth it. I mean, this job I done it just for the sake of the live stream. But I'm charging a flat fee for this board, so it's not really worth it. But now you know how to do it if you have same problem. Good. Heatsink. What the fuck, man? What was that? Let's be sure it didn't damage anything. No. But you can see the screwdriver mark there. Ah, lucky. Okay, let's put the board back quickly. The live stream yesterday, the problem is I'm getting awake like 2, 3 o'clock in the morning. So basically, like 12 hours later, I just, run out of batteries. So that's what happened yesterday. It was supposed to finish this job from yesterday. I'm up at 2 a.m. Yeah. But it's one thing to wake up like 2 a.m. in the morning or going to sleep to 2 a.m. What is wrong with this connector? Why is not going inside? With the fingerprint thingy. Yeah, okay, all good. You're buying spare boards? No, the customer sent me the spare board. The customer sent me the spare boards together with the jobs. I do have some spare boards, but not that many. But I'm trying to get more spare boards. I have a customer last week. He left for spare Asus gaming laptop, which is like a bad liquid damage, proper bad. I told him, I can't do it. I can't even start it, no even point. The other side of the board was all rusty. And yeah, and he said I can keep it for spares. So if the customer said I can keep it for spares, then I canceled the invoice with the postage and the diagnose fee, so everyone was happy. Yeah. Let's plug the charge. No charging. That must be a battery issue. Or the battery is too low, or is fully charged. And we have picture, and if we are taking this, yeah, the battery is fully charged. Escape to continue, and all good. We fix it. Great. Fixed. Good. Next one, no driving power. Okay. Oh, why here is no capacitor job, huh? What happened with the capacitor jobs? Plug in the charger, 5 volts with no current. 5 volts with no current. Here is a fly. I have a fly on my room. Yeah, the fly went out. No lunch break? Nah. Nah, if I have lunch, I'm going to sleep after that. You seen what happened yesterday. I don't want that to happen again today. Okay, so why this one is not working? We have 5 volts with no current. Let's check for short here on this power supply, which is creating the main power rail. So checking for short. Here is the input, and it's not short. And here is the output, and it's not short. So nothing is shorted. Then the MOSFETs and the PD controller. Let me check quickly. At 5 volts. So at the input of the MOSFET we have 5 volts, and at the output we have 0.5. What do you think about that? So it's either the MOSFETs or the PD controller. If I short the input of the MOSFET with the output of the MOSFET, it's taking like 200 milliamps, rebooting, and we have 19 volts. Check there. 90 volts at 200 milliamps, and it starts charging and all that kind of stuff. $20 volts. Oh, what was that? Bad MOSFET? Yeah, but I don't want to replace MOSFETs anymore. I mean, you can see by the color they're kind of gone. But can be the PD controller. Can be the PD controller. But the thing, the PD controller is negotiating the voltage. So how you can explain that? Hmm? So here we have 4.9, and at the output we have 0.5. But this MOSFET is looking good. Huh? The other one, 5 volts. Here we have 4.9, and at the output, and this is the output, we have 1.4. So what we are doing, that's the question. What direction we are going? No glue, really? Yeah, no glue. Ha! A MOSFET is easy to be taken out. Let's take out our MOSFET and check the solders, because it has to be blow up in order to not drive like any power. So we are taking quickly our MOSFET out, and we are looking at the MOSFET, at the back of the MOSFET. Use wire, we can't, because here are like 2 ports. And then the power is going from one port to the other, and we can lead to a different issues with this particular customer. Kind of neat, he's kind of like a neat guy. The package is coming like nicely packaged with the attention to the detail. So I don't really want to play with this particular one. Yeah, it's burned. It's burned. Check that. You can see by the pin it's burned. You can see that pin is burned. Check that. You can see the pin. And on the back, check here there, it's blow up. So this one is blow up, this one is blow up. Check here, you can see it's black, has no solder, nothing. They are like flat, not even solder. I know I was joking. Okay. You can solder, you can breach them. These MOSFETs you can breach them. Definitely you can breach them. So those MOSFETs are gone, both. I mean, I don't know what to say. You still getting the solder on them? Probably not. I don't even have the solder anymore. Let's see, maybe we can recover the MOSFETs. Any flux. Huh? We are getting the MOSFETs back on track? False? You have to stay positive and optimistic. Huh? Okay, let's replace the MOSFETs with different MOSFETs. The pads are burned, that's the thing, the pads are burned. So we still have one MOSFET from that board. Do you heard about the repair law? Yeah, right of repair, yeah. Yeah, but nothing really is moving there. I can't see anything to get changed. I mean, I wish I can do more for this law. But what can I do more? Hmm? Okay, where is the other board with the MOSFET? MOSFET. Yeah, here. Here we have one MOSFET. This one. Good. They said the parts must be available. They don't care about that. They can easily say, okay, this is a secret, so we don't want to share the technology secret with other people. They should start with Intel and Nvidia, because you can't buy CPU, you can't buy GPU, you can't buy chipset. They should start with the big fish. That's all what I'm saying. They should make an example for a big from a big company, AMD and Intel and Nvidia. The parts will be a complete new motherboard. Exactly. Exactly. They cannot comprehend there are actually people able to fix the motherboards. Because they can't. They have no people fixing motherboards. They can't. So they cannot comprehend, wait, the people actually can fix motherboards. 19 volts and no current. But that's good. That's a good sign. And this one is still 5 volts. No, we need one more MOSFET. So one is fixed. So this is one thing which is pissing me off. They believe, okay, we are such a smart company. We create such a smart laptop. No one can fix it. No one can figure it out because they are stupid and we are smart. No. 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 This is not smart. Smart are like actually devices, they are working over like 20 years. 20 years later, the device is still working. That's smart. That's it. What is actually smart. That's a smart design device. Your device, which just died after the warranty, is just dumb and stupid. Let's see what we did. 19 volts. Must be 19. Oh no, it's 5 volts. Hmm. This one it is 19, 20 volts. But this one we messed up with that MOSFET. It's not soldered properly. One gate is not touching. Okay, let's see what's going on there. So here you have 4.9 and the input is 4.9. Okay, it's not the MOSFET issue here. No. Here is 20 volts, so it's working fine. We have 20. But here is something else. Well, let me try 19 volts, I see in there. No, even if I short the fence, it's not working yet. Let me try from the other side. It is possible we have some kind of like port issue. Not sure what should I say. I'm not receiving notification for your live stream. You go on YouTube and you have to activate the notification. You have there the bell and you have to activate the bell and set up all notifications. 800 milliamps. So the MOSFET, it is providing power. It's not the MOSFET here. 2.8 amps, you can see. So it is providing power, the MOSFET. Yeah, and the voltage is getting dropped. 4.3, but it's not getting dropped over the MOSFET. Yeah, that's very important. So here, this one is working fine. 19 volts, 2.1 amp, it is charging the battery. $18.8 and the input is 19.2. This will blow up again. 19.5 and the output 18.8. This is the chip fault. This is the chip fault. But the other one is not the chip. 4.3 and the output is 4.3. So the MOSFET has the right voltage on the gate. Check the gate voltage. You can't check the gate voltage, Thomas, because the gates are under the MOSFET. How you can check the gate voltage? Yeah, we have to replace the PD controller. 11:30. Just another long job. The switcher BGA chip, yeah. Let's replace that chair. Okay, give me like 1 minute. I need my cigarette. Okay. Sorry for that. Everyone is good, huh? Enjoy the Sunday. No barbecues today? Yeah, if you ask me, this is like kind of boring because you are fixing exactly the same laptop model. So I understand. It is boring. See if it's yeah, my puppy, my dog is here. So we have to replace the PD controller, right? That's what we said. Finish dinner? I'm getting hungry. So we have the PD controller, which is a AD1, and I'm gonna use one which I took it out earlier. AD. Perfect. Check the solder bolts. Huh? So this is faulty. I shall not use this on any kind of form of shape. Good. AD. Good. Pin number 1. Here. And the PD controller is soldered. Let's see. 5 volts, no current. Okay. This one is not working at all. Nothing. And 5 volts with no current. Nah, it's not working. And I'm pretty sure I soldered that chip properly. I mean, we can push the chip down, but not sure if it will make any difference. Musaka, we have Musaka Milan like 2 weeks ago and was so good. I think she made the best Musaka ever. So yeah, I won it. I won a Musaka, but I don't think she will do. So now the both ports are working, but both are working with 5 volts. I'm not negotiating the current. So I don't think this PD controller is good. We need another one. Let's take this chip out. The chip is out. Let me solder this one, yeah? This chip. Let's do the solder bolts. Good. Number one here. Okay. Amar, you're here? But this one is not working. This one is going to 19, then it's going to 0. Okay, let's push the chip down. Actually, we can't push the chip down. But the chip has a crack on a corner. No, we need another chip. We need another one. I think this one is AD, but I'm not sure. It's AD. Okay, we're gonna move that chip. Good. Good, perfect. And the chip it is soldered. Good. $19 volts. Huh? And this one? 19 volts is rebooting. Why is doing this? Okay, this is weird. 5 volts from this side. And this one, 5 volts from this side. Huh? It's not 19 anymore. 5 volts, 1 amp. It was 19. It was working and now it's not working. That's really interesting. 1.7 volts. We have no voltage at the input. That's crazy. This is a port issue. This is a port issue, a charging port issue. We have no voltage at the input. Must be a port. If it's not a port, then so the voltage is coming from these fuses. It's coming from here, and here is 0. It's coming from here, and here is like 5 volts. Lol. Okay, and here is 5 volts. Okay, so this thing is not working. No, this one is not outputting voltage. U194. Let's check online. Let's go to the schematic. (194). Probably is the PD controller. Probably is the PD controller. (194). So what this chip is doing is taking 20 volts and it's getting enabled. Check here, it's getting enabled from here. So this is doing nothing. It's just a MOSFET with an input and an output and an enable pin. Wait, has an AC or K pin? It's not used, right? Probably not. Must be the PD controller because it was working before. Okay, so has a over voltage protection. This is over voltage protection. Cool. So what we learn from this? We learn we can skip this chip. If we are skipping this chip, what will happen? How we are skipping the chip? Very simple. By shorting this with this, like that, from here to here. Nothing happened. Wait 1 second. No. From here to here. And it's 5 volts and 800 milliamps. Five volts we have 800 milliamps, and on the other port we have 5 volts with like 200 milliamps. No, with 800 milliamps. So the chip is not getting enabled. Why the chip is not getting enabled, huh? Power shutdown. That was right. Enable power shutdown. A1. A1. Okay, where this is going? Well, this is going to that chip and This is the BQ chip. Power shutdown. Not sure what should I say. Oh, so basically the signals are together. Yeah, A1 with A1. So both chips are shut down by the BQ chip. Oh, check the MOSFETs again. No, it's not the case. Whoa. Let's check the PD controller. Why this capacitor has 7 ohms? Huh? 5 ohms. And this capacitor has 5 ohms. And this capacitor has 5 ohms. And this capacitor has 5 ohms. Why? Why we have 5 ohms on the capacitor? You don't know, right? Yeah, that's what I thought. I don't know either. Ooh, come on, man. It's 12 o'clock. So here it's taking in 200 milliamps. Let's see what is taking 200 milliamps. The PD controller is shorted. Check there. So the PD controller probably died now, because I seen at some point that we see 19 volts. Then I plug on the other port and yeah, went to 0. Ports and 90 volts, the CC lines, I don't know. Not sure. But we found another chip, another PD controller. So we're gonna remove this PD controller and then we're gonna replace it. Okay, the chip is out. Then we have this one. Perfect. Ah, I burned my hand. Should be soldered. Check for short on caps? No, I don't know the caps. 5 ohms. Very unlikely. We can check, of course we can check. I know the caps. No. No, infinite resistance. You see? Infinite resistance. Plug in the charger and have 5 volts. 5 volts, exactly like before. Exactly like before. Five volts and 5 volts. Exactly like before. No, infinite resistance. Yeah. Okay. That with the controller. I mean, this board is like liquid damage, so it is possible this PD controller actually died. We need another one. Brand new one we have. Brand new. AE. And this one. We can't see. AD. Can you believe that? Ha! Let's solder a brand new one. Huh? Proper brand new one. What do you think? Like a proper brand new one. Can we do it? Brand new chip. Pin number 1. What is pin number 1? I can't see the pin number 1. Hmm? So according with the writing, the pin number 1 is on the corner. So this has to be with the writing up, right? Yeah, like that. Yeah, we have a brand new chip now. "19 volts. And this one is not working. Nah. But on this one we have 19 volts. Okay, so we know that one is good. From this side, 19 volts. Check that, 19. And from here, 19 volts, 800 milliamps, 1 amp. But here it's not starting. 1 second, the board is not starting. 20 volts and the board is not starting. Why? That must be related with the MOSFETs. 1 second. So here we have 0. Here we have 6 volts. No, nothing. No, 20 volts here, and at the output we have 0. Yeah, so this MOSFET is not doing the job. Now you understand how complicated are USB-C power-related faults? Yeah. Crazy, it's insane. Okay, we soldered that MOSFET. "19 volts, 20, we know current. This MOSFET is not good. So here we have 20, and at the output we have 0. No, something is wrong with that MOSFET. You see, it's nothing worse than a USB-C job. And many times the customer, it's a port issue. No, it's not a port issue. No. No. No, it's not working. This MOSFET is not doing the job. So the PD controller, it is negotiating the voltage. Well, let's take out the MOSFET. So why this MOSFET is not doing the job? That's my question. I mean, the chip position is right, huh? Must be. You still here? Okay. No, the MOSFET is dead. We need another MOSFET. Let's replace the MOSFET. Good, so the MOSFET it is solder. And it's not working. Ha ha. We replaced the MOSFET for nothing. I can't believe. Why is not working? We have 20 volts at the input and 0 at the output. Okay, let's see. No, on the other side, we have the MOSFETs and we have the gates. Yeah, where is going? So this one is going straight to the PD controller, right? Not to a resistor. And from the resistor is going to the PD controller. Okay, worth to check that resistor. Probably not. Then we have the next gate, which is here. And this one is going to a resistor, then it's going to the PD controller. So we have two resistors here. Let me try to localize the resistors. two resistors there. And then it's going to the PD controller. So let's check together on the diode mode to see if the pins are connected. So this one, and we have reading, and this one, and here we have reading. No freaking way. So actually they are going to the PD controller. Then I don't know what to say. We replaced the PD controller with a brand new one. We replaced the MOSFETs. Why is not working? Why? Maybe because it's Sunday, you think? You pull a bad MOSFET, hopefully it's a fix on the beginning. Yeah, you remember? 5 volts. It's not even negotiating the voltage anymore. It's gone. 5 volts. Yeah, not working anymore. 5 volts, 5 volts. Yeah, clearly a PD controller issue. Fantastic, at least we know something. Let's see. Five volts. I think we are killing the chips with too much heat. And I have like what? 400 degrees. Otherwise I cannot explain what's going on here. So the chip just died again. We had like 5 volts. I mean, I can't even trust the chips. Maybe the chip came faulty from the factory. We don't know. We have no idea. I'm gonna replace the chip one more time with a brand new one. Because why not? Why not? No, everything is fine here. Yeah. Okay. They hate the heat. Yeah, but it's not that high. 1 second. Wait a sec. Wait. I have more than it's. I have like 470. I can't believe. Okay, it's my fault. Yeah, probably I killed the chip with the hit. Yeah. Yeah, definitely I killed the chip with the hit. But the chip it is solder on place. $19 volts. Okay, 800 milliamps. 5 volts because why sure work. Yeah. Then from here we have 19 volts with 800 milliamps and 19 volts with 1 amp. So that MOSFET is good actually. I should keep this MOSFET safe. Missing paths, no. So the only problem right now left is actually this port from this side, from here. We have like 5 volts. Do you think it's actually a port issue? Or I'm dreaming? Dreaming, right? Sorin is dreaming and he's not even sleeping. You know what, let me replace the port. Just to be sure. Let's replace it with this one. good. Plugs. The port, which is looking dodgy. It's looking dodgy from now, before soldering. Can't believe it. No freaking way. Come on, man. It is Sunday. I want to go. I want to eat. I want to play with the dog. We have one laptop left. This one and one more, and that's all. We can go. I have a feeling this is not soldered properly. You have a USB port tester. 5 volts. 5 volts. So it's doing exactly like the port from before, and from here is 19. It's not the port. It's not the port. It's doing exactly the same. So this one has a chip. This chip, yeah, from here. This must be the issue. This one. This must be the problem. This chip is handling the CC signals. Why this chip is not moving? Okay, now it's moving. Good. Nah, it's not working at all now. Nah, we broke it. It's not working at all. Nah, dead. Yeah, this one it is working, but this one is gone. So we have to replace that chip. Actually, I would love to bridge that chip. I would love to bridge it. Good, so the chip is out. And we need another chip. Like this one. Oh, come on, man, I can't believe. Okay. Let me grab another one from here. This one. Good. The chip is out. Oh, the port fell down from the board. Can you believe that? I mean, this is my board. Yeah, it's my board. Can you believe actually the charging port fell down from the board? Okay, so the chip it is soldered. And I'm gonna solder back the old port. And this one. I mean, hopefully it's working this time. Because I really had enough from this board. With so many faults. 19 volts, okay. I will take it. 19 volts and it's working. 19 volts and it's working. And 19 volts and it's working. I can't believe. I can't believe. Wait, let's solder that port properly. 1 second. We didn't solder the port. I mean, this one is from the factory. Okay, this one. Yeah, but you see how much work is on a job like this? If I'll tell the customer, it will not believe me. And this job is made having spares, yeah? We have spare components, spare boards. Just to understand how tricky it is. Oh, here is a fly on my roll. I can't even do it. Okay, we need a heat sink. You know what, Amr, you'll laugh. But I do have a customer exactly like that. We send the motherboard for the laptop for a port. Of course, it was not the port; it was the PD controller, and that's what he said. He said, "Why you charge me that much? Because I send the laptop for a port." Yeah, it was a customer from a computer business. Anyway, exactly. And I explained him it is not the port. It was a PD controller and MOSFET, and it was a long job. So if I will not have a video as a proof, they will not believe me. They will think I'm some kind like scammer. Like, okay, that was a port and he charged me more for different kind of stuff. Good. Good. Guys, you know what will happen because I'm proper hungry. I think I'm gonna stop. I'm gonna stop here, and I know we have one more laptop, but I will do it off screen. I need my food. Then here is proper hot. I need a shower because I'm all sweating here. Then is Sunday, and today I plan to wash the pavement outside on the garden. So I still have some things to do. We spent like what, like 3 hour and a half here together. Three hour and a half on a Sunday. With a water hose? No, with a high pressure. Thank you, Mati, and thank you guys for being here. Actually, because otherwise, if I have no one to speak with, it will be extremely boring, and I cannot make the live stream public because I will be too concentrated on the chat, and I cannot handle the jobs. You sacrifice your Sunday for being here. I deeply appreciate it. Now what okay. What do you roll here? Good, so everything is connected. I think it's time for testing. We need a battery, which is here. Plug in the charger, so the battery will charge. 3 amps, check that, 3 amps. 3 amps. Beautiful. It's everything about the current. Everything is spinning around the current. But I think if I fix more than Lenovo ThinkPad X1 Carbon, I will get some brain damage. Really. I mean, why they didn't use like normal MOSFETs? Cecil, thank you very much for the donation. Thank you. Why they didn't use like normal MOSFETs? Why they feed that rubbish flat surface MOSFET with no cooling? Cooling only from the board. Didi's on the chat. It's not about that, it's about the design. I mean, okay, the PD controller, it's easy to be replaced, but it's glass. The MOSFETs are glass. So you have the most sensitive components from a laptop, they are glass. Pablo, thank you very much. Yeah, food. We need food. Imagine fixing without swearing. And we have picture. Check that. Yeah, it's working fine. Escape. Yeah, working fine. It's taking like 3 amps, so everything is fine. Yeah, Diana knows. Diana knows, swearings and stuff. Yeah, she knows. I'm getting angry. I'm getting pissed off most of the time. When something is not going as planned meaning as easy pizza job, then yeah, a lot of swearings. Fantastic. We need a sticker. We fixed, yeah, because we fixed it. Fixed. Great. Okay, guys, I'm gonna stop now. Again, have a beautiful Sunday. Enjoy the day. Do whatever you like. And see you next week. Yeah, I have a bunch of jobs. I will try to publish more videos. Okay? Cool. Thank you for being here and, getting bored with me together. See you next week. Yeah, enjoy the day. Have like a good food. Bye, guys. Bye.